Okay, guys, welcome to session 11. Carrying on with graphs in session 11, we're looking at translating graphs. Another fairly big topic when you hit it A level, so hopefully this will help. You would have seen a bit of it at GCSE, but maybe not all of it. So there could be a bit of new stuff today. Okay, let's get cracking straight in. Okay, translating graphs. We're going to start by looking at translations. Now remember, translations is just a movement up or down or left or right, or a combination. Now if I just look at the graph y equals x squared, okay, now hopefully you'll know that this just looks like a U-shaped parabola passing through 0, 0. Y equals x squared, okay. Now if I was to draw, so if we have that as our set graph, if I was to draw y equals x squared plus 2, now what will happen to that graph, it will just shift up 2 spaces. So the graph will shift up 2. That'll be y equals x squared plus 2. All the coordinates of the graph on the y just go up 2 spaces. So that's our red graph. If I was to look at y equals x minus 2 squared, okay, you might think, well, what's going to happen to this graph? Well, every x coordinate is going to have to be 2 more. The graph is actually going to shift to the right 2 spaces. Okay, and the reason for that is if I put 2 into this equation, I get 0 as an output. So I put a 2 in, I get 0 as an output. That's my blue graph, and that will shift to the right. It's a bit opposite, it's a bit counterintuitive. Okay, so that will shift to the right too. So in general, for translations, if I have a graph y equals fx, that just means anything in terms of x. It could be x squared, x cubed, 3x squared plus 1, anything you want. Then y equals fx plus a, well, think about what that would do to the graph. That will be a translation by the vector 0 in the x and a in the y. And that still works if it's a negative as well. If it's a negative, it just moves down. Okay, so that's the first rule to know. Second rule, if I've got f of x plus a, here we had minus a, but it works the same way. This will be a translation by the vector. Well, it's always the opposite sign there, and that's in the x direction. So that's minus a, 0. Minus a, 0. Okay? Right, I'm just going to lose a quick example on that. So EG1. If I had a graph that looks like anything you want, I'm just going to put that coordinate in there as 2, 4. And this one is maybe 6, minus 4. You might be asked to sketch, let's say this is y equals x, sketch and label the coordinates. Sketch and label the coordinates a fx y equals fx plus 1, b y equals f, let's say x plus 2. Okay, so this is how the question would be worded. Now the first one I'm going to do in red again. Fx plus 1, well, that simply just shifts the whole thing up 1, and all it does is change the y coordinate by shifting it up 1. That's going to be 2, 5. The whole thing is going to shift up 1 space, and I do need to label the coordinates. That's going to be 6, 3. That only affects the y coordinates. Okay. Now the b, that means it's going to shift to the left 2 spaces. Okay, so that only changes the x coordinate. So this point is going to end up here on 0. In fact, the whole thing Just going to shift over to the left, and that coordinate there will now be 0, 4. The y coordinate this time remains unchanged. That'll be 4, negative 4. Okay? And there you go. Now, on the worksheet, you'll notice today there's 2 separate parts. I'm going to teach it all in one go, and then at the end you can sort of go through and answer both sections. But if you want to pause the video now and do the first half of the worksheet questions, you may. I'm going to carry on and look at the next sort of transformations, which you may not have seen at GCSE, and these are stretches. Okay, stretches. Right, what I'm going to do is I'm going to quickly draw out a sine graph. Now, you may not have seen this, but the y equals sine x has this sort of shape. It's a wave, it goes between 1 and -1. And it passes through 180 degrees and 360 degrees. That's the standard y equals sine x graph. Now, if I was to sketch y equals 2 sine x, okay, so this time it's not sine x, it's 2 sine x. What happens here is, I'll do this one in red, all the y coordinates double. So the y coordinates times by 2. Okay, that's where the 2 sine x coordinates unchanged. Okay. Now what this does to the graph is, okay, well the y coordinate there is 0, so that's not going to change because 0 times anything is 0. But here the y coordinate's 1, so it's going to shift up. The x coordinate stays where it is. Again, 0, it's not going to change. Here it's going to shift down. And there you go. So all the y coordinates have doubled. It's now going to vary between -2 and 2. But the x coordinates, crucially, haven't changed at all. Okay, so that would be y equals 2 sine x, and it is stretched in the y direction. Now if we look at the other sort of example, you might get sine 2x. So how would we sketch that one? And I'm going to do that one in blue. Well, this one, all the x coordinates are actually going to half. So y coordinates unchanged. X coordinates, you're going to divide by 2 because you're timesing it by 2 there. You need to divide by 2 to sort of counteract that. So what's going to happen is this point here is going to shift in there, but all of these points are going to shift in by half. It's going to shrink this curve. It's going to basically squeeze it into sort of double the frequency. Okay, so that there, all of that graph is squeezed in. And that's y equals sine 2x. Okay. Again, y coordinates haven't changed, so it hasn't stretched at all in the y direction. Right, let's look at in general then. So in general, if I have y equals fx, again, some function of x, could be sine x, could be x squared, 3x squared, anything you want, then y equals a fx. Well, what's this going to do to the graph? It's going to stretch it, parallel to y-axis by scale factor a. Okay, that's what that will mean. Now, in reality, what this will actually mean is the y coordinates you times by a and x coordinate unchanged. Okay, if you were looking at specific coordinates. Okay, so that's the first case. Second case is if you've got y equals f ax. Now have a think about what we did with the sine one. This is going to be a stretch parallel to x-axis, but this time it's shrinking, so it's by scale factor 1 over a. Okay, and then in reality here, y coordinates unchanged, x coordinates you times by 1 over a, or you divide by a. Okay, so they're the two cases there. Now there are a couple of special cases of these. special cases which you do need to recognize. So if you have y equals minus fx, so if there's just if the scale factor is -1 in the y coordinate, well, you might have a think about why this would happen, but you're timesing all the y coordinates by -1, which what will happen in reality, this will be a reflection in the x-axis. Okay, that will be a reflection in the x-axis. All your coordinates have flipped sign, effectively, the y coordinates. And likewise, f of minus x, scale factor is 1, so -1, so 1 doesn't change the shape of it or the frequency, but this will be a reflection in the y-axis. Okay, so there's some special cases you need to watch out for. Okay, I'm going to do one more example on these, and then you can get cracking on the worksheet. So EG2, looking at stretches. If I had a function, it could be anything. I'm going to draw a wiggly line. I'm just going to say that coordinate there is 2. Or same as before. This one, 6 minus 2. This is y equals x. Could be asked to sketch and label coordinate. Let's say y equals 3x. B might be y equals f of 2x. Okay. Now the best thing you can do here, if I do the first one in red again, this just means I multiply all the y coordinates by 3. So this, for this point here, is going to end up being up here. It's going to be 2. That's going to be 212. Okay, and this point here, that's going to go down here, 6 minus 4. And then the shape of it is that's still 0, 0. It's just going to stretch it. You don't have to be too worried about that's going to be 0. You have to go through the key points. And there you go, y equals 3 fx. Okay. The second one, all we're doing is shrinking it, the x-coordinates. We're halving all the x-coordinates. I'm going to do this one in blue. So this coordinate's going to go here, which will be 1, 4. This coordinate's going to go here, 3 minus 2. And the whole thing is just going to shrink it by scale factor. Yeah, so we don't actually know what happens after here. I'm going to have to stop there, I'm afraid. Okay, so that is the lesson on state. Again, the worksheet, please, can you complete every question? There's a few bit of sketching involved here, but remember, sketching is only really you're interested in the key points. You don't have to draw it to scale. So I want you to do the whole worksheet. It's in 2 parts, so you'll do the translating questions first and then the stretches afterwards. Okay, right, well done guys, and tune in for session 12 shortly. Thanks a lot.